BAP Union, pride of the Peruvian Navy. A majestic ship stands out among the others on the coast of Callao, Peru. It is the BAP Union, the first Peruvian Navy four-masted sailing training ship. The ship is 115.75 meters long and 13.5 meters wide. It has a total of 34 sails with a sail area of 3,402 square meters. Its main engine has a power of 1,400 horsepower, which allows the ship to reach a maximum speed of 12 knots. The BAP Union was built by Servicios Industriales de la Marina, SIMA, in Callao, Peru. It was launched on December 22, 2014, and delivered to the Peruvian Navy on January 27, 2016. The first step is to design the ship. Engineers use specialized software to create the shape, structure, size, materials, and other specifications of the vessel. Once the design drawings are complete, the shipyard begins preparing materials and equipment for construction. A large ship is broken down into many smaller components that are then manufactured and welded back together in the correct order. Stage 2, Sheet Metal Cutting. First, the sheets are coated with primer and then transferred to the cutting shop on a conveyor. Using information from the computer, an automated cutting machine cuts the sheets to the exact specifications of the design drawings. Each sheet is marked with a unique identifier before being sent to the assembly shop. Stage 3, Assembly of Sections and Overall Segments. During the assembly process, the individual sheets are welded together to form sections and overall segments. Assembly follows a specific process, with flat components such as frames and cross members being assembled first. The curved components are then welded in place. The welding process is carried out on a conveyor. Up to 20 to 30 overall segments can be assembled in the shipyard each day, each weighing up to 300 tons. Forging the seas, ship plate steel, the backbone of ocean giants. In the heart of the shipyard, where metal meets ambition, lies a hidden hero, ship plate steel. This robust material, woven from carbon and its alloyed brethren, forms the very skeleton of the leviathans that conquer the oceans. Its strength, a whisper forged in fiery furnaces, lets it shrug off the might of waves and the fury of storms. Ship plate steel is no mere metal sheet. It's a testament to human ingenuity, meticulously crafted to meet the unforgiving demands of the sea. Tensile strength, as taught as a sailor's grip, ensures it won't buckle under the crushing weight of cargo and the ocean's embrace. Ductility, the silent partner to strength, allows it to flex and bend without snapping, weathering the unpredictable dance of the tides. From the cavernous hull that cleaves the waves to the intricate latticework of the superstructure, ship plate steel reigns supreme. It forms the lifeblood of the vessel, carrying fuel in its steel veins and housing the beating heart of the engine room. Every deck plate, every bulkhead, whispers a tale of this remarkable material, its silent symphony echoing across the endless blue. But ship plate steel is more than just strength and resilience. It's a canvas for innovation, a platform for cutting-edge technology. Engineers bend and weld it into intricate shapes, coaxing it to become the sleek lines of modern vessels, the graceful curves of racing yachts. And as the demand for cleaner seas rises, ship plate steel adapts, evolving into forms that minimize environmental impact, leaving a lighter footprint on the waves it conquers. The standards of ship plate steel are regulated by ship classification societies around the world. These standards ensure the mechanical, chemical, technical, and quality properties of ship plate steel. Chemical composition of ship plate steel. Ship plate steel is produced from carbon steel and may contain some other alloy steels to improve mechanical properties and corrosion resistance. The main chemical composition of ship plate steel includes the following elements. Carbon. Carbon content increases the hardness and strength of steel. Silicon. Silicon is often present in steel as an intermediate element, affecting the pig iron refining process and the mechanical properties of steel. Manganese. Manganese is used to increase the hardness and wear resistance of steel. It can also improve the weldability of steel. Sulfur. Sulfur is often present in steel as a tramp element, helping to improve machinability and weldability. Phosphorus. Phosphorus may be present in steel as an impurity element and needs to be controlled during production to ensure the quality of steel. Nickel. Nickel is used in ship plate steel to improve corrosion resistance and withstand dynamic pressure. Chromium. Chromium has the ability to increase hardness and corrosion resistance of steel. Molybdenum. Molybdenum is often used to improve mechanical properties and corrosion resistance of ship plate steel. How steel ships are welded. Steel ship welding is an important process in the shipbuilding process. It helps to create strong and durable welds, which help the ship to withstand the forces of waves, wind, and water. Steel ship welding is a complex process that requires the skills and experience of qualified welders. The process is typically carried out on a production line, with steel plates being welded together in the correct order of design. There are many different welding methods that can be used to weld steel ships. The most common method is arc welding, in which an electric arc is created between an electrode and the welding material. This arc melts the welding material and fuses it with the steel plates. Another method that is commonly used to weld steel ships is flux cord welding, in which a layer of flux is coated on the steel plates. This flux helps to protect the weld metal from oxidation and creates a stronger weld. After welding, the welds are inspected to ensure that they meet quality standards. Defective welds can be repaired by re-welding or by cutting out and re-welding. The ship's propulsion is supported by a diesel Caterpillar 3516H engine, a Bird propeller, a Rolls-Royce maneuvering propeller and a Reinge's LAF 863L gearbox. The Caterpillar 3516H is a powerful diesel engine that is used in a variety of industrial applications. It is known for its durability, reliability, and fuel efficiency. The 3516H is a 16-cylinder, 4-stroke engine that produces up to 2,000 horsepower. It has a displacement of 157 liters, 9,600 cubic inches, and a bore and stroke of 170 millimeters, 6.7 inches, and 215 millimeters, 8.5 inches, respectively. The engine is turbocharged and after-cooled, which helps to improve its performance and efficiency. The 3516H is used in a variety of applications, including construction equipment, mining equipment, oil and gas drilling, marine vessels, power generation. The 3516H is a popular choice for these applications because it is reliable, durable, and fuel efficient. It is also relatively easy to maintain. If you are looking for a powerful and reliable diesel engine for your industrial application, the Caterpillar 3516H is a great option. Hull assembly, a symphony of structural mechanics and maritime prowess. The assembly of a ship's hull transcends mere construction. It is a meticulous ballet of material science, structural engineering, and hydrodynamics, orchestrated by skilled artisans. At its core, This process revolves around crafting a robust and resilient vessel capable of defying the turbulent caprices of the ocean. First movement, forging the skeletal scaffolding. The ship's frame, akin to a meticulously articulated vertebrate, forms the foundation upon which its entire being rests. Steel bars, chosen for their exceptional tensile strength and resistance to corrosion, are meticulously welded or bolted together, their intricate network meticulously designed to distribute load and withstand immense compressive forces. This skeletal framework establishes the ship's overall geometry and serves as the anchor point for the subsequent layers of the hull. Second movement, crafting the impenetrable armor. Next, like cladding a knight in impenetrable armor, steel plates are strategically positioned and meticulously fused together. These plates, ranging in thickness from centimeters to several decimeters, form the watertight shell of the hull, the vessel's first line of defense against the relentless pounding of waves. Precise calculations ensure structural integrity while minimizing weight, allowing the ship to achieve optimal buoyancy and agility. Third movement, orchestrating the dance of forces. Beyond the brute strength of the frame and the stoic resilience of the plating lies a nuanced play of forces. Internal bulkheads and stiffeners are strategically positioned to resist torsional stresses and prevent buckling under the ever-changing loads exerted by the sea. Careful consideration is given to factors such as shear forces, bending moments, and the propagation of stress waves, ensuring the hull maintains its structural integrity even in the throes of the most violent storms. Fourth movement, a tapestry of functionality and aesthetics. Finally, the symphony of assembly culminates in the intricate details that make the ship not only seaworthy but also aesthetically pleasing. Cladding adds an additional layer of protection against corrosion and wear, while meticulously crafted decks and superstructures offer functional spaces for crew and cargo. Decorative elements, from elegant railings to bold paintwork, add a touch of human artistry to this marvel of maritime engineering. Hull assembly is more than just the sum of its parts. It is the culmination of scientific understanding, engineering prowess, and meticulous craftsmanship. Every weld, every rivet, every plate tells a story of human ingenuity and dedication to conquering the ever-changing canvas of the sea. hull of the ship was completed and launched on December 22, 2014. In June 2015, the ship received the mast and propeller, and interior finishing began, led by the contractors Akapafi and MO Contract. Its sail rig is composed of 24 sails from sailmaking company Weenek, arranged in bowsprit mast, foresail mast, mainmast, mizzenmast and jiggermast, with a total sail area of approximately 4,324 square meters.